So just to start, just to tell you a little bit about me. My name's Chris Brownlie. I'm an analytics consultant at Barnet Waddingham. Been here for about a year now. Before that, worked for the Department for Education, and I've got nearly 6 years' experience with R and Shiny. And at Barnet Waddingham, I'm in the management decision analytics team, where we provide analytical solutions to a variety of clients in different industries. And my role in the team is to act as basically a source of expertise on Shiny and processes and our working practices around Shiny. So, Anatomy of a Shiny app is a bit of a strange title that probably doesn't give too much away. An alternative title, which might be more informative, is a sort of high-level look at the Shiny source code. So this will be theoretical and sort of quite technical, particularly in the middle, but I will get to what the point of it is at the end, so stick with me through it. I won't be talking about these things, so they are very important for a Shiny app. JavaScript and WebSockets, sort of related to what George was talking about before, deployment and infrastructure, which Liam was talking about, and UI design, which I know there's a couple of talks on later. They're obviously very important for a Shiny app, but what I'll be talking about in this talk is more the sort of the R code in the Shiny package and sort of what's going on under the hood of that. So why the word anatomy? This is because I have an analogy which has helped me kind of understand, build a mental model for Shiny apps, an alternative to Liam's car analogy. And if you think of a Shiny app as a person or perhaps an animal, you can think of the UI being the stuff that you can see. So like the size, the shape of the body, the facial features. The server being like the brain, which takes in information, does calculations, gives information back. And so in this analogy, what I'm going to be talking about today, the Shiny package and other packages that Shiny uses, you can think of as providing the organs for the app. Most of the stuff is hidden. You don't kind of see it, you don't have to worry about it, but without those organs, the app would fail. So using this analogy, you can think of developing a Shiny app as a bit like designing a video game character. So you get to choose what they look like, size, shape. You get to choose their attributes and characteristics in the same way that you get to develop the server when you're building a Shiny app. And you don't have to worry about the organs. I'm sure there are some video games where you can, but for most of the time when you're designing a character, all the sort of internal stuff is just sort of taken care of. You can interact with them indirectly by, saying if you want your character to have increased stamina, you could say it results in like bigger lungs or whatever, but you don't directly interact with them. They're just sort of taken care of, and so you don't need to worry about them. So what I'm hoping to achieve with this talk really is the two things, three things there. I think it's very easy to use Shiny and do lots of stuff with Shiny without having a good mental model or understanding of what's going on under the surface. And I think that's by design, really. Shiny purposely abstracts away all of the complexity of building a web app and makes it very easy for new people to get started. But I think that does mean that you can end up in a situation where you're building very, very complex Shiny apps without really understanding what's going on under the surface. So hopefully this will kind of help rectify that a little bit. The second point, demagicify, which is absolutely a real word and not made up. I think when people are new to Shiny, a lot of what goes on with building a Shiny app seems like a black box, and it's kind of hard and intimidating to see what's going on. So hopefully this will encourage people to dig a bit deeper and kind of get a better understanding of what's going on under the hood. And the reason for that is that third point that I think both of those things, being less intimidated and having a better mental model of what's going on under the hood, can help you avoid common mistakes and build better apps in the future. So what I'm going to be talking about today really is R6 classes. For those of you who don't know, R6 is a package which provides a method of object-oriented programming. It's sort of an alternative to S3 and S4 if you've used them. It's implemented very differently. If you've used Python, an R6 class is more like close to a Python class, really, Python object, than it is to S3 or S4 in sort of how you interact with it. You don't need to know in detail kind of what R6 is or how it works. All you need to know is it's a way of providing classes, so each objects have classes. So for example, data frames, tibbles, etc. That's S3. R6 provides an alternative way of doing that, and one key characteristic of it is reference semantics, which, again, I won't go into detail. It's not particularly important for this talk, but I would encourage people to go and look into it, because knowing that and the opposite of that, which is what base R uses, can be useful. But it is used extensively in the Shiny package, R6, and R6 classes to kind of manage what's going on, all the complex objects and behaviors that go on under the surface. So this is all the R6 classes that are provided in Shiny. I've very subjectively just ranked them or rated them based on how important I think they are to the sort of core of what we call a Shiny app, and then how complex they were, or how complex they are, at least to me, seeing them as, for the first time and trying to understand what they do. So in the top right, we have these classes which are very important to a Shiny app and also quite sort of complex. So the objects with those classes do some sort of fancy coding stuff that is very important to how Shiny works. I've sort of classed them as core classes. In the bottom right, you've got things which are complex and they do difficult things, but you don't necessarily need them for a Shiny app. You sort of have to opt into them. Things like bookmarking, file uploads, progress notifications. In the top left is the classes which are simpler. They don't do necessarily really complicated calculations, but they are still part of sort of what makes Shiny shiny. And then in the bottom left, we've got helper classes, which are sort of very simple classes, particularly map and mutable, which are basically as simple as you can get for sort of R6 objects. So this is all the things that Shiny provides. You don't need to know sort of what they all do. I'm going to talk about a few of the ones in the top right, because we, as Shiny developers, will all interact with them, even if we don't know we're doing it. And I'll talk about sort of how we interact with them, with the wrappers around them that Shiny provides. So when are objects with these classes created? Because what I've shown you there is obviously classes of objects, but at some point Shiny creates those objects so that it can then use them when the app is running. So there's sort of these 4 different places where these objects are created. Some are when the app is first loaded. So the handler manager, for example, holds the sort of HTTP web server that Shiny uses, and the reactive log is also initiated when the package is loaded and sort of lasts throughout the R session. When the app first starts up, it creates the Shiny session, which those in blue, I'm going to talk a bit about sort of specifically what they do and what they're for, but the Shiny session, which is arguably the most important and the one that potentially we interact with the most. That's when the app first starts up. And then in the app event loop, so Shiny kind of boils down to a while loop of while the app's running, check if stuff needs to be done, and then do it. And reactive environment and a lot of the core helper classes that are in the top left of that diagram that I showed, they sort of handle that. And that's kind of where all the reactivity happens. So all the actual sort of magic of a Shiny app happens in that event, app event loop. And the last ones, the bottom ones, which are the sort of user-dependent ones. These objects are created depending on the developer when they want to use them, how they want to create them. And you can see in brackets the sort of functions which are probably familiar to a lot of you. And that's kind of how we interact with them as developers. But when where they are used depends on individual apps and app developers. So the first class I'll talk about is the Shiny session class. For most Shiny apps, when the server is initiated, it's initiated with an input-output session argument. That session argument is an instance of the Shiny session class. It's in some ways the overarching class of a Shiny app session. You can sort of think of it as like the top level or the home of the app. And it's how Shiny accesses a lot of the optional classes and the other core helper classes. It accesses them through the Shiny session, so it's sort of a very important object for a Shiny app session. Arguably, the most important job it does is communication with the client via WebSockets. So, sending messages to and receiving messages from, which is sort of, without that, we wouldn't have reactivity. Another important job is handling outputs in the server, so taking in what we provide via render functions, making sure that knows when one of its inputs changes and it needs to be recalculated, and initiates and manages those app cycles I was talking about of invalidating objects and requiring them to be flushed, which is some terminology which I'll get onto on the next slide. But yeah, it basically boils down to keeping track of things that need to be done and make sure they keep getting done until there isn't anything else left that needs to be done. It's also the sort of gateway to things like bookmarking and modules and file uploads and that kind of thing. So it's a very important type of object. Two of the most important classes which don't have a visible wrapper, and you probably wouldn't interact with directly anyway, is the reactive environment and context classes. So the reactive environment is an object which keeps track of contexts, which you can think of as sort of the reactive objects in your app. The reactive elements all have a context associated with them. It's kind of just a flag, you can think of it as. So they keep track of when things need to be recalculated and what actually needs to be run to recalculate them and other things that depend on them. So there's two sort of key bits of terminology there which are used in Shiny, invalidation and flushing. So invalidation is just saying something that I use in this value has changed, so I need to be recalculated at the next earliest opportunity. And then when it's recalculated via a flush, it's called. And so the reactive environment and the context basically is key for keeping track of that. So when an input value changes, so for example, something in the UI changes, it sends a message to the Shiny session to update the value of an input, a reactive value, that then invalidates anything that depends on that. It invalidates the context of anything that depends on that, and that notifies the reactive environment and the session that they need to be flushed and recalculated in the next run of the app event loop. So reactive environments and contexts, very important objects that you don't really need to know about. They just sort of handle the reactivity in the background, but just to, sort of give you some insight into that. So moving on to some things which are probably a bit more familiar, or at least the functions that we use to interact with them. Reactive vals and reactive values are objects which are called reactive producers a lot of the time. It's basically a way of storing a value that can change and using that, keeping track of things that use that value. So it's a class that has methods for setting and getting a value, and when you set the value, it it notifies dependents of that value that it's changed, so that they then know they have to recalculate at some point. So it keeps track of the dependence of that value explicitly as part of the object itself. Reactive values is very similar, but it is a different, distinct class. It's not just a list of reactive vals. It's a distinct type of object. It does the same task, but it also has to keep track of things like names and keys and stuff, because it has multiple values which might change. So yeah, it boils down to the same thing really, that it's just a value that has things which depend upon it, and those dependents need to be invalidated or recalculated if the value changes. So that's kind of when we use reactive val and reactive values in a Shiny app. The next one, again, is probably familiar to a lot of people, the observe and observe event functions. They, behind the scenes, create an object, which is of the observer class. It's essentially a function that has a context associated with it and can be invalidated. So all it means is it can be invalidated by things it depends on, and that then signals to Shiny that needs to recalculate the value for it. So it watches for something to change and then runs some code in response to that, basically. So yeah, other objects invalidate observers. So reactive vals and observables, which are on the next slide, they can interact with objects which are of the observer class and invalidate them. So it watches for things to change and then performs an action in response to that. Observable, this is kind of potentially the most confusing in the way that it's named, because we interact with it with a reactive function. It's called reactive expressions in a lot of the documentation. It is sort of a mix between an observer and a reactive value in that it can do both of them. It can do the same thing as both of them. So like an observer, it can be invalidated by things it depends on. So it can take in reactive values and change in response to when they change. But it can also be used in observers itself as well. So it's sort of in between the two, where reactive values can notify other things that they need to recalculate. An observer can be notified, an observable can do both. And so that's the reactive function, creates an observable object. So that was sort of a lot of technical jargon which might not make sense to people if you're not familiar with classes and object-oriented programming. But I promise I'd get to what the point of it was. So this is kind of why I think this stuff is useful, particularly as you start to get more advanced with Shiny apps. And I've personally found it useful when trying to describe Shiny to other people or teach about Shiny, because maybe it's just a personal thing, but understanding how things work under the hood, I think, make it much easier to find different ways to express how things work, and that then makes it easier for other people to learn. So there are some specific sort of common design mistakes which I've seen, which I think understanding this can help with. So the first one, reactive versus observe, knowing when to use reactive and when to use observe, which is something I think that a lot of beginners really struggle with. I know Joe Chang did a talk a few years ago now on basically when to use each and the difference between them, and I think that was sort of spurred on because a lot of beginners really struggle to understand what each one's doing. So I think understanding what those functions create under the hood, the objects that they create, and how those objects work can help to reduce incorrect usage of those functions. It provides a sort of a different view to look at it. So understanding that, it basically boils down to, do other things need to know if this value changes? And does this need to happen in response to other values changing? And the answer to those questions will give you one of those three objects, which you can think of as the functions that you use to interact with them as well. The second point is very related to the first point. So trying to reduce the amount of reactivity that's happening. So perhaps a better way to word that would be overly chatty expressions or expressions which run too often is a common source of Shiny apps slowing down, not being very efficient. So yeah, understanding kind of how observers and observables work when they're invalidated and how that then triggers them to be recalculated, I think can help to understand kind of how the reactive graph is constructed and try to sort of reduce the amount of times things are run using functions like isolate and so on. Because yeah, understanding that in the Shiny session or in the functions when the event loop keeps running, everything has to be sort of flushed, and that can slow the app down considerably. So I think understanding the sort of subtle differences between those classes and how we interact with them can help. And then that third one there, misunderstanding modules. I think it's when you're new to modules, understanding kind of or getting a sense of what namespaces are doing and what a module's actually doing when you use the call module function or the module server function, and understanding that it's the Shiny session is sort of like the home sort of top level of the app, and modules sort of come off that in a hierarchy, can be helpful when you're thinking about interactions between different modules or different sort of parts of that hierarchy in the app. So just to wrap up, 99% of us will never need to know about those classes and objects which I've just sort of explained. Shiny's been specifically designed that way to sort of abstract away from having to understand them and having to interact with them directly. And Shiny provides sort of wrappers and an interface to manipulate them in the way that you need. But I think having a good mental model, from my personal experience, is something that people struggle with the most. They can kind of point out what functions they need to solve a problem, but understanding what those functions are actually doing under the hood, I think, is a very useful thing and can help avoid some common pitfalls. I think in general, understanding the tools we use better is good, and sort of how they're built. I think it can lead to more sort of conscious design choices and designing apps in the way that Shiny basically designed them to be built. So following a Shiny philosophy, basically. And then just for fun, on the final slide, as I was going through the Shiny source code, sort of putting this together, I came across some comments which, as part of demagicifying Shiny, just sort of wanted to point out that the people who develop Shiny are human beings like me and you. They run into the same frustrations and difficulties. So these are some of my favorite comments that I found going through the Shiny source code. So, thank you.